Super excited to be here. This is a great event, and I love to see when the community actually builds something up that big. So big kudos from my side. We're going to talk about how to go global in minutes with the help of AWS, and I will highlight a couple of services to you, how you can achieve that, no matter if you're at the beginning of your cloud journey, in the middle, or even maybe more advanced. Short intro to myself. My name is David Heid. I'm a solutions architect with AWS, in fact, for 3 years. And since 1 year, I'm working in the EMEA game tech team. And that means I work exclusively with game tech customers. Customers that produce games, customers that publish games, customers that stream games, or everything that's related to the gaming industry. On a personal note, I'm a passionate do-it-yourself hobby worker. I love playing video games, of course. And my all-time favorite is the Legend of Zelda series. So what are we going to talk about today? First of all, we look at all the architectures that we see with our customers as AWS solutions architects, and what challenges come with that in terms of how to get your games as close to your players as possible. And then we talk about the different services that can help you here on this journey. Let's start with the architectural challenges that our customers have. There's the option to deploy in a single region. That means you have everything in one place, and from there you serve it to all your players, which is really great because then you have one source of truth, one point where your data is. All the decisions come from one point. You don't have to centralize it. You do not have the danger of running into a split brain scenario. But of course, this can have a much higher latency depending on where your players are located. So what a lot of customers and gaming companies do, they deploy multi-region just to be very close to the players. And you see, there's only one pro I highlighted here in the list, but in fact, it's the most important one, and it outruns all the other cons that you might see here. But still, when we look at the con list here, this is a lot of work to do. Actually, whenever I run 2, 3, or even more regions, I need to make sure that my data gets back to one central location where I can process it, analyze it, make decisions, and then ship these decisions or deploy these decisions that I made again to my edge locations. So it can be very cumbersome to run in many regions, but of course it's worth the challenge. No question about that. So how can we as AWS help you there? Before we go deeper into the services, let's look at Amazon Global Network. Currently, and this is the date of the 10th of July, just for the sake of the fact that this meeting is recorded. We have 25 regions, 81 availability zones, and more than 230 points of presence. And this is what you see in this graphic here. And it also shows that all of this is connected. And when it's connected, this is not connected over the public internet. No, in fact, this is connected over a private, redundant connection that we as AWS maintain. That means whenever you move traffic from an edge location to an AWS region, or from an AWS region to another AWS regions, it does not travel over the public internet. It travels through an Amazon managed connection, which guarantees you stable latency, high throughput, and basically no jitter at all. And this is essential to understand the benefit of all the services that I'm going to talk about now. Let's look at content delivery and HTTP APIs. And you might want to agree with me that all game workloads start with HTTP, like for authentication purposes, for matchmaking, like all the things that need to be done in order to find a management language with your server. It's usually HTTP that you use. Let's look at one case study here, Social Quantum. Social Quantum migrated one of their major games, Wild Wild West New Frontier, to AWS in 2021. And this allowed them to basically switch down 50 of the 300 servers they are currently running on premises and reduce the overall complexity of their games while saving a lot of cost for them on CloudFront. Let's look at the use case of content delivery. Of course, whenever you are shipping content from your game that is similar or can be reused by many customers, content delivery makes a lot of sense. Because, well, it's an asset that is static. Why not cache it somewhere where it's really close to your players? First of all, it reduces the costs. It helps you fend off the load from your origin server, and you have a better performance. And imagine if you're shipping a really big asset, like, for example, a day one patch or something like that, content delivery will really have a massive effect on this. But also if you have like dynamic assets to build dynamic levels or such things, content delivery will also help you a lot, keeping the things simple and saving cost. Now, when we talk about HTTP, when it's not static but dynamic, most people will say, well, a content delivery is only for static. That's not entirely true. Amazon CloudFront can work fully dynamically. So you can run a dynamic API and distribute that globally via Amazon CloudFront. And let me show you one thing that is really outstanding here. And this is because of the Amazon Global Network. So when we have a request coming from a player, it hits our edge locations, and from there it travels over the Amazon Managed Network directly to the AWS region where your origin server resides. Now, since the connection between the edge location and the region, this is AWS, we can keep that connection open. That means all following players that utilize the same edge location can reuse that existing connections. And if you look at this from the TCP point of view, where you have a handshake, like a SYN, ACK, and then the data exchange starts, one of the round trips is saved because the connection was held open by CloudFront. This is what you configure with a so-called origin timeout when you have a CloudFront distribution, and it can really help you to speed up the interaction between your APIs and the players. Of course, if you talk about two opposite places of the world, distance is still distance. So we cannot magically somehow jump with light speed, but we can nearly. And one round trip saved over a long distance is actually a big thing. So it could be enough for your business to decide, well, in this case, we don't need to deploy in 2 or 3 regions. Maybe we just utilize CloudFront for that. Keep the stack simple, keep the cost low, but still have it fast and sufficient enough to serve all your players. So whatever you do with CloudFront, we can agree that the better the latency, the better is the player experience, right? So what you want to achieve is to have the possible closest distance between your players and the content that is delivered. So caching is a strategy that should be massively utilized when we talk about Amazon CloudFront. Because even if you have dynamic parts of the API, there are certainly also static parts, and the static parts should be a part of the cache and should be part of the architecture that you build. Let me explain that a bit when we look at well, I made this up, but an RPG balancing API. So let's say you have a multiplayer RPG game and you run this globally, you distribute it globally. And there are certain things that might be cached when we, for example, look at the name of a player or the avatar image of a player. This certainly does not change every second. So you can probably cache it for a minute or two, maybe even 50 or 20 minutes. This will already offload a lot of the work from your origins. However, when you have things like hit points or anything that is highly dynamic, of course, you mustn't cache. But again, you have more assets that maybe never change or very, very rarely change. For example, NPC values or some static configuration. And you can utilize CloudFront to cache even parts of a fully dynamic API to make the overall experience for your customers and gamers much faster. Now, when we look at our customer Pretty Simple Games, this is a very small startup. Maybe they have grown in the meantime, but still, when you have limited resources, the key to success or the key to moving forward in a business is that you use a service that is fully managed. And this is what they did with CloudFront. They just have a small team, but CloudFront can be fully self-operated by any developer. So it gives them a massive benefit to reach global scale. Another thing is pricing. And this is, I would say, one of the big changes when you look at Amazon CloudFront while you are on AWS already. I mean, the pricing can be seen on the website, but there is one thing. So if you have an AWS origin, the data transfer out costs from the origin to Amazon CloudFront are completely free. We do not charge for that. You only pay for the data transfer out to the internet from Amazon CloudFront in this case. So let's say whenever you are using a CDN currently and you're paying double, which is the Amazon data transfer out costs and the CDN costs on top, with CloudFront, you would actually save this part of DTO costs already. And if you are over 10 terabytes a month or bigger in your data out per month, there is the option to have a private pricing agreement together with us, and then you can expect really good benefits that drive the costs even more down. Yeah, what if you're already using a CDN? It's really easy. Just use 2 CDNs or more CDNs. And that sounds a bit funny, yes, but it's actually true. If your whole business depends on one CDN, you should really think about a multi-CDN strategy. And I mean, there are lots of difference in CDNs, and we see a lot of customers that use a multi-CDN strategy, either for redundancy or business continuity, but also to reach maybe certain parts of the world where the one or the other CDN is not available or not so good available as the other. So it's a thing. What you can do, but the challenge with multi-CDN is if you use 2 or 3 CDNs, you have 2 or 3 times the load again at the origin, because every CDN wants to cache the contents themselves. So if your purpose or if your intention with the CDN was to offload your origin, you increase that load again with a multi-CDN strategy. And if we look at this from AWS, there's one component that is called Origin Shield. You see this at the very right side of the slide. So Origin Shield is basically another layer. And let's maybe quickly explain how Amazon CloudFront works here. So as you can see, Amazon CloudFront is a so-called multi-layer CDN architecture. My slides are here, so please excuse me, but I'm not looking at you. So we have lots of edge locations, I think 220 or even more currently. And we have the so-called regional edge caches. And when the first user comes, they hit the edge location. After that, the regional edge cache, and then the origin, or in this case, Origin Shield. So as you can see, it is an optimized traffic flow that aims to reduce the load of the origin a lot. And if you use multiple CDNs, this third layer called Origin Shield can reduce the load of the origin even more. Origin Shield makes really sense when you are offering a lot of static assets and a lot of a good amount of data, but also if you're, for example, live video streaming. Another thing that you can do with CloudFront is edge computing. So you can have application logic at the edge. And Lambda at the edge has been around for quite a while. What's relatively new, though, is CloudFront Functions. I will explain what both do in the next slide, but both technologies share the same characteristic of serverless. That means You don't have to manage server. You don't have to take care of provisioning or scaling. It just works as you go. You only pay for what you use, and it has the standard built-in reliability, availability, and fault tolerance that you know from AWS Lambda already. Now, where can you use it? So Cloudfront Functions is JavaScript only. So it's ECMA script 5.1 compliant JavaScript, and it has a different characteristic that AWS Lambda. Well, you know probably from AWS Lambda that it can take some time to warm up, and this is not the case anymore with Cloudfront Functions. So Cloudfront Functions run instantly with less than a millisecond execution time. The trade-off is you cannot have network connections with Cloudfront Functions. So let's talk about possible use cases of Cloudfront Functions or Lambda at the edge. Let me unfold all of that. So what we see a lot here is that at the viewer request, and that means when the visitor hits Cloudfront and Lambda at the edge or Cloudfront Functions can intervene before that traffic or that request hits Cloudfront. What a lot of customers do here, they use this for rewriting rules, but also for normalizing the traffic, for example, making everything lowercase so that you have a better cache ratio in Cloudfront then. Did I say rewrites? Of course, standard rewrites, shortcut URLs, everything that you would do, you can also do this with Cloudfront Functions quite easily. And you can implement much more, for example, A/B testing directly at the entrance level of your application. Or you can evaluate if, for example, a JSON web token or something similar is valid and then let that user pass or not. So it's exciting how many things you can actually do. And basically the only limit is your imagination here. Let's recap all of this and maybe give you an overview what is really the differentiator of Cloudfront. I mean, what's true with Cloudfront and actually most AWS services is it's fully self-service. So it's available for every developer. You do not have to call someone to create a Cloudfront distribution or sign a contract or anything. All you need to have is an AWS account and you can get started. We have a huge Amazon Global Network, and we are, sorry, that number is wrong, it's 230 and more. We have a huge Amazon Global Network, and we are extending and expanding constantly. Most importantly, you can integrate everything that you do with Cloudfront or with Lambda at the edge. You can integrate that with all the other AWS services. And if you are on AWS already, you probably know what a benefit this brings when you connect this to, let's say, S3 for access logs, then analyze this with Athena, for example, have all the metrics in one place, be it CloudWatch. It's really endless in what you can do in your possibilities. The data transfer out costs is really a big thing. And as I said, it's really a changer for most of our customers. And of course, we are not talking about security today this much. In fact, if you're interested in security, I'm having a talk at GDC where I talk about game server security and also talking about security at the edge. But when you use Amazon CloudFront, you can have AWS WAF enabled to inspect the traffic inline and react to possible threats already. Supercell is another customer of AWS that uses Amazon CloudFront. But in fact, not only Amazon CloudFront, Supercell uses Elastic Computing Cloud, Amazon S3, and they do incredibly meaningful things with AWS. For instance, they store 10 terabytes of games event data each day and process and transfer that with Amazon Kinesis. Leaving the world of HTTP, entering the world of TCP and UDP, because if we are talking about multiplayer game servers or game servers and backends that need a high rate of data exchange and a low latency, you will probably run TCP and UDP. And here the service to use is AWS Global Accelerator. Another customer example, Joect. They rolled out AWS Global Accelerator for the use of 80% of their games. And on average, they saw a reduction of network timeouts by a factor of 2.4, like more than double less timeouts occurring than before. And not only that, they also saw a drop in their complaints from their gamers, meaning that the change actually happened and was noticed by the players as well. How does AWS Global Accelerator work? Well, let's say you have the scenario that you deploy to 2 regions and you have players connecting to your endpoints and they would travel a long distance. With AWS Global Accelerator that works with the Anycast network, you have global statically available Anycast IPs that can be used at the edge locations directly. So it's part of the Amazon managed network of the edge locations that I presented earlier. That means your players can connect to edge location via Anycast, and from there the traffic goes over the Amazon managed network, which is much faster and more stable. In general, you can have a lot of benefits when you look at the comparison between the public internet and the AWS managed internet or the AWS Global Accelerator. So it's not only about latency and throughput, it's also about the first byte latency, which is important because new connections can sometimes be a bit longer. So this is also important to look at the first byte, but also at the jitter. Depending on how your game operates, the less jitter, the better. And you can be more flexible in designing the player interaction when you can rely on low jitter in general. Let me show you some use cases and coming back to what I've shown in the very beginning, how you can use AWS Global Accelerator. For example, you have this multi-region deployment that I talked about, but still there is only 25 AWS regions only. And maybe there's one region where the continent is still quite large. Let's say South America in this case. And you have players from Chile that you want to connect with players from Brazil. What you have only the region in Sao Paulo. What Global Accelerator can do is you can deploy Global Accelerator only in this region. You receive an Anycast IP that is available in, for example, in the edge location in Rio, but also in the edge location in Santiago de Chile, and then traveling over the Amazon global network. And that means you can basically let these players play together on low latency. But you can also use it to simplify existing deployments. Let's say you have 2 AWS regions. I chose here Seoul and Mumbai, both Asia Pacific regions. And you say, well, we deployed there in 2 regions because we wanted to have the better latency. But it can be that if you utilize Global Accelerator, that you can completely go away from one region, shifting the traffic maybe to only 1 instead of 2 regions. And that means, of course, less operational overhead, but also it will save you cost, assuming that you have in every region that you deploy some kind of ground level of application stack that you need to run in order to have the application as it is. So this will help you simplify, but also reduce the overall cost a lot. And of course, you can, like you did, we saw this with Cloudfront, you can deploy this also on a global scale, utilizing the Amazon managed network on a global level. What has been also introduced, well, not recently, I think it was at reInvent last year, is the so-called custom routing. Custom routing lets you basically define a routing table on your Global Accelerator IP that you have a port mapping to an instance and target port in your Amazon VPC. And that can be an instance but it can basically be any VPC resource that you have. For instance, an EC2 instance, for example, an EC2 instance, but it can also be a Kubernetes pod. Also, custom routing is very flexible. So you can, for example, reroute the traffic dynamically with Global Accelerator custom routing. Give you the opportunity to, for example, have your matchmaker attached to this and bringing players from different geos together. One more service that I'm going to talk about is AWS Outposts. Let me again tell you a story of a customer, in this case, Tipico, a sports betting company based in Germany. They wanted to enter the US market to expand their business, but US regulations require that every online bookmaker maintain the data on premises within the state where they operate. So they had to deploy infrastructure where they wanted to operate in the US. What they utilized for that is Outpost. And Outpost is basically a server rack that you can order from AWS and we ship it to the location where you want to install it. And the cool thing is it gives you the same experience that you have with AWS. It's the same API. It integrates into your VPC. You can use the same tools for automation like CloudFormation or Terraform, all of that. And you can basically just extend your AWS experience to one virtual region. Let's make a bit quicker here. Almost done. So one use case that we see here, we have, for example, the US here, where we have only East Coast and West Coast. But what is if we have players in the middle of the US that we want to connect? So the solution is deploy an outpost and have these players in the central region connect to each other and experience a better latency and be able to play together. Last but not least, Amazon Route 53 helps you to organize all of this on the DNS level, and you can do a lot of things with Amazon Route 53. Like from basic, simple DNS routing, you can have a weighted round robin, meaning you, for example, can do some kind of canary deployments on DNS level, but also you can have failover routing, geolocation-based routing, and so on. So it's really a very, very powerful and versatile service that you can use at the very, very first point where your users arrive. So let's look at that again. We looked at the single region deployment and the multi-region deployment. So what is actually best? Well, I explained a couple of scenarios, but we can also agree that every game server architecture, every backend is unique. This is why we exist, AWS Solutions Architects, and it's not only me and the game tech team. In fact, we have a couple of solutions architects around. And when you are on AWS and when you plan to use one of the services that I just shown, give us a shout. Let your AWS account manager know, and we will be in contact and help you guide through that and understand where to place it best. That was me, pretty much on time. Thank you. It was great to be here. I hope you enjoyed the talk. Catch you soon. Have fun.